This time I have a piece of radio history here from the Lower Mainland. This piece of equipment was used at CKWX Super Country when they were a country music station. It's the mixing console that they used. Well, not the on-air mixing console, though this one was in a production studio where they did commercials, and the monitor is not working. The right channel of the monitor is not working. So it was brought out to me to see if I could figure this one out. I do have the service manual, so that's going to make things a lot easier. But this one here, well, the right channel just kind of hums. It doesn't know the words. Anyway, let's check this one out. This is something that most people have never seen. I'm kind of teasing you guys. There will be people that know what this is. Clue? Does that give you a clue? Nice big meters. Things are bigger than my hand. Still guessing what it is? This is a Harris Stereo 5 radio console. This one actually came out of a radio station. This came out of CKWX 1130 in the Vancouver market. The guy that brought me this was a former DJ back when they were a country music station before they became all news. They are now known as News 1130, but they used to be a country music station, and this was one of the consoles. This actually was not the on-air console. This was a production console that was used to do radio commercials. It's a 5-channel stereo mixer, of course, back in the day. Well, they were stereo back then, right? They were AM stereo. So they had a stereo console in there. They obviously had to put a stereo console in when they went stereo back in the 1980s. So this was a production console. The problem with this is one of the monitors, the studio monitor, one of the amplifiers is dead. I think he said it was the right channel. Anyway, we're going to hook this up to some speakers and hook an input up to it and see what's wrong. I got the technical manual here for it, so I've got what the engineers would look at. And you know, you would think, well, if you're a radio station and you're spending, tens of thousands of dollars on equipment, then at least they could give you the stupid manual for free. Nope, they had to buy the manual. This manual is from 1975. That gives you the vintage of this unit. And these would have been used in FM radio stations back in the day as well. Very common console back in the day. They got all the original engineering notes for it. It's got no cover on it. It's probably installed in a console and they just slid it out. But there would have been a cover that went on the thing. Either that or he took the cover off of it. He may have had a cover on it. He just brought it to me with no cover. Here are our specifications. So as a frequency response up to 30 to 15 kilohertz, and that would be for a reason, because on FM you can't broadcast beyond 15 kilohertz, so there's filters that will cut that out. I don't know if this has got the filters on it. Normally they're at the transmitter, but they don't need to go beyond 15 kilohertz, so they don't. It's EQ'd, I'm sure, for that. Does it say what our power output on the monitor circuit is here? Does it say? It's probably only 10 or 15 watts per channel. But does it say what it is? I like this. Muting and warning lights. A protective system of warning lights and speaker muting is provided to prevent acoustic feedback and broadcasting of a cue signal when live microphones are nearby. So channels 1 and 2. These are the microphone inputs. They have low noise preamplifiers. Channels 3, 4, and 5 are designed for medium level inputs. So turntable preamplifiers, cart machines, reel-to-reel, etc. I'm just reading the manual here. So these are headers for the input. There's inputs on the top here. There's only, this one's got channel 1 and 2 hooked up. This one's only got channel 1. So you could have like microphone 1, microphone 2, microphone 1 and microphone 2 for the second channel. Typically, like your DJ would be on one of these ones. and your studio mics, one or two, or if you're interviewing somebody, you'd have microphones, or the DJ would be on one and whatever. But they had two inputs for microphones. There's only ever been three that have ever been hooked up here. You can see the wires here that are hooked up onto the headers. This one's never had anything hooked up on it. We're not too worried about the those. And then on the other side over here, these are the line level inputs, and as you can see, they've only ever hooked up the first one for each of these. Right, channel 1, channel 1, channel 1 on these switches here. These show up on these controls here. I do have the full schematic, so this one shouldn't be too difficult. Looks like it's using a pair of Darlington transistors for the outputs here. This is the right channel here. There's an op amp, and there's a pair of Darlington transistors. I'm guessing that's these ones down here. First, let's hook it up to some speakers and an audio source and just see what it does. So this is the input-output panel. Everything's on here, so this is just an empty box, basically. The engineer at the time put all the wires onto here, and we've just got channel 1 and 2, channel 3. These are the audio inputs, channel 4 and 5. Microphone would have gone there, for example. And the inputs here, channel 4 and 5, and channel 3. We're going to just hook up one of these to a source. And anyway, our speakers are going to be connected over here. Okay, so I've got it plugged in, hooked up, powered up. Immediately I hear a humming coming from the right speaker. If I turn the Q up, I got the sound from the Q. To get sound out of the output on this thing, it's on this one. I got to put it in program. There we go. So I got nothing out the right channel. It is humming. It is humming, so let's get the scope out and see where we're losing the signal. I just discovered something else on this. It might be a stereo 5 board, but it's configured for mono. So even though it's got the 2 meters on it, both meters swing, but they both swing to the same input. Because this is a balanced input at the back. Doesn't matter. Input 3 is a balanced input. Doesn't matter what I hook up to it. It's a mono input. It's not wired for stereo. It's only wired for mono. The other input was probably on the here, like it's wired to these headers here. It's left input. That's probably the right input there, and for the other input, the left and right. Maybe I don't know. Looks like it's only configured for mono though. Only configured mono. Because it doesn't matter which input I use. Like I've only got one input hooked up now, and both meters are deflecting. So I should be hearing sound out of both speakers. If I put my scope down here on the emitter follower, I have indeed audio. If I go over to the other channel and look at this one, all I see is some ripple. I'll show you guys the scope. So there's the left channel, as you can see. I'll go to the right channel, check the same. It's hard to get in here with the scope probe. And there's the right channel. It doesn't matter what's on there, that's all I get. So our problem is in this stage here. I'm going to look at the op amps to see if I've got any signal driving. There's also a lot of corrosion around here too. It looks like something got spilt inside here, so that may be part of the problem. I'm just going to check some of the levels here and see what I can see on my scope. This is the left channel, so give it some volume. So here's our op amp that drives it. This will be the volume control over here. I think this is the monitor control there. It's 2U12. It's an NE531 op amp, and that's going to drive these Darlington outputs. So I should have audio going into pin 3 and audio coming out of pin number 6 on this one here. 2V12 or 2U12? 2V12? It's hard to see off it on the monitor. My monitor is not a high definition one, so it's hard to see. But let's look at that. See whether I've got any audio there. So I got no audio. You guys couldn't see what it wasn't framed up there. But I got no audio going in or coming out, but I do see a DC shift on pin number 3 when I turn up and down the volume. If I go over to the left channel, for example, this is it here. Pin number 3 is the input. And I got lots of nice input there on the scope. And I look at pin number 6, which is the output over here. And I got drive coming out. So this is pin 3 for the left channel, the input to the op amp. And then the output is this one here. And you can see when I turn it down. And if I go over to the other side, this is pin 3 for the right channel amplifier. Yeah, when I turn the volume control up and down, it does that. So it's before that. We're not getting any audio, and there's the output, of course, from the op amp. So we're not getting any audio going into that op amp on the input. Just kill the power here, save the speaker. I could swap these two op amps around just in case the op amp's at fault. They're the same, so I can pop these out and they're socketed. So let's try that. Let's swap these two around first. Actually, I should be able to just pull them out with my fingers. There's one out right there. Oh. Okay. The top half of the socket came out with it. Yeah. Old electronics, but we'll just we'll pop the other one in place of it. And they're facing the opposite direction, so I gotta turn it around. Because this is just for the low level output. So if I pop this one in here and get sound, then we'll know that the fault is the IC itself is bad, the op amp, which is a possibility. Okay, that's in there. Let's try it now. Still doing the same, so we know it's not the IC. All right, testing back, the next stage back, U8. I have audio. This is the program level that the monitor is being fed off of. So I have signal there. That's the right channel, and then the left channel is this one over here. Yeah, and so that's it's good here. It's good here, it's bad over there. If we follow the print, our audio is good over here. This is the output that we just looked at. Where was that IC? Here. The audio is good there. And then it goes through a couple transistors and ends up over here. I haven't checked it here yet. And then this goes through the balanced output for the program out. He didn't say the program out was bad. So I wouldn't expect it to be bad here, but I got good audio here on pin 6. That you guys can't see because it's off camera, but it's that one there. A good audio here. From here it goes into a couple transistors and then into a transformer to feed the right program output. It feeds off of here and it comes back down and it ends up over here on the monitor control over here. And the monitor control goes straight into IC12, U12, and I got nothing on pin 3. Just that AC signal. So somewhere between here and back here is where the problem's going to be. These are the transistors here that follow the output from the amplifier. So let's just look and see what signals we have on those transistors. Should be looking at the emitters. The emitters are the output. Yeah, the emitters are the output. Collectors go to plus and minus 15 volts. And the emitters should be where my signal is. Audio, or whether I have distortion. I have audio, it looks like. That's the emitter. It's emitter collector base. I have audio there, and I have audio here. So that's good. So it's good at that point. So and I would have expected it to be good because he told me that the line output worked. And if we look on the print, we're good here on the emitters, which goes into this transformer, and then it goes to the line output. But you see, it also comes down through this resistor and connects through, I guess this is at test point 140, 111, and then it says 40 on here. That's the wire. And then from here it comes along and it goes along and it ends up right down here on the program switch. And then from here it goes into the monitor level control, and from there into here. We got a blocking cap here. It's a pretty simple circuit. Not a whole lot to go wrong with it. But it's good here, and it's bad here. Outputs could be bad too. I haven't discounted that. We could have a short output, but typically you would end up with a DC voltage. If the output was bad, you'd end up with DC voltage. You'd blow the fuse. You blow the speaker fuse, because there's the speakers connect here, right? You got control room monitor, lobby monitor, and studio monitor, and they're controlled through relays to turn them on and off when you hit the mics, for example, to kill the monitors in the control room. So C79 possibly could be shorted. This one here is a blocking cap on the input. If that were to short, and the fact that I'm seeing DC swing when I turn up and down the control, that cap could be shorted. C79, it's a 47 microfarad. It's a possibility. Where is it? Let's find it here. This is it here. It's a tantalum cap. It's 47 microfarads, and we are measuring, if I can get my probe on there properly, yeah, I think we're pretty close there. I don't think we're going to find any shorts on this one. Hmm. 79K. I don't think so, but it could be leaky. I could be reading some internal resistance from the IC as well on pin 3, and there are other resistors in there. 100K resistor, yeah, that's what I'm reading. I'm reading that 100K resistor, so I don't think we're looking at that. Alright, I've got disconnected the monitor control to verify everything's good up to and including the control. What I did find is if I put my meter across what is the input, I'm getting a DC voltage of about 8 volts, 8.5 volts. This is the input to the amplifier. Now that's going through a blocking cap and into that op amp. You guys want to see shoddy work? Look at this. This was done by the radio station engineers that were maintaining this when this was a working board at CKWX. Look at this. Like, what the hell is that? Is that somehow converting it from stereo to mono? Looks like someone's done some fancy work in there. And just let it sit there. Just, oh, the hell with it. Just stuff it under here. Nobody will see it. Yeah, okay. I see it. I don't know what it does. I don't care what it does. Contrary to what some people would think, this does not operate at high voltage. It's operating at a plus and minus 15 volt. If I look at the right channel, it's got two separate power supplies. If I look at the plus supply, the 15 supply, you can see the meter. So on the right channel, positive supply is just one of the ones here. You have 15 volts, 13 volts. As soon as the power goes off, it drops to nothing. The negative supply for this one drops off a lot slower, right? You know, so that the positive supply, it drops like instantly. If I go to the left channel, which is this one here, positive supply, you'll notice it drops off much slower. So we have something loading down the positive 15 supply on the right channel. So the positive supply comes up to the right channel here. It only goes to two places. One is to the output transistors and the other is to the op amp. Positive supply is dropping. I'm going to disconnect either R127 or just connect the collectors for Q7. and see if the voltage drops off as quick. Alright, I disconnect the collector for Q7. That's the positive output. We'll take a look back at the power supply. Oh look, the hum's gone away and the voltage drops off much slower. That transistor must have internal leakage. I'll disconnect it and measure it. It's a Darlington transistor. I don't know if I'm ever going to find one of these things, but it looks like it's that transistor that's gone bad on this one. And I disconnected it, and of course the hum went away. I guess I could probably check to see whether I've got my audio going into it now. I believe this was the bass here. Yep, I got audio. Yep. And of course, if I reconnect that transistor, I'll just use my scope probe to reconnect it. Our noise comes back. Wouldn't you know, Lee's had the transistors in stock. I went in and picked them up. Let's change them.
I gotta get out the TV turner for this one.
And I forgot how much I enjoy driving downtown during the week. And I'm being sarcastic. It took me over 2 hours to get down there to pick up the 2 parts and drive back. It's ridiculous. The amount of traffic in the big city. That's why I never go there. I hate the traffic. Well, this new transistor I just got is it's the same number, TIP 140, but it's in a different case. The TIP 145 is in the same case. I got both of them, so I had to modify the leads a bit. Hopefully it'll fit. And we'll get some heatsink compound on. And then place the transistor into the board. And the mounting hardware. Now there is a spacer on here, so that it doesn't short out. Gotta make sure that that's in well, and then get the nut on the other end. That's gonna be the fun part. It's gonna be even more fun to do this one with these resistors in the way. All right, that transistor's installed. I didn't have the camera running because my head was in the way, but we're gonna check to make sure that there's no short between the collector and the heatsink, which is not, so my insulator is good. Now, to change this one, which is going to be another fun challenge. I guess I have to remove these resistors. They're screwed down, right? There's screws that go down to hold them in place, and the nut on the bottom. They're soldered down too, so if I remove the screw, can I move it over enough? That's the question. Can I move it enough to get in there with the screwdriver too? There's a resistor in here that supplies a negative voltage to the op amp R135, it's a 100 ohm resistor. Wonder if that's any good. Let's just check and see. 100 ohm R135, where is it? Right here. Okay, let's check this resistor. Let's see if this resistor is measuring 100 ohms. That looks like it's open, that resistor. It wasn't touching there. There we go. I think that resistor's open. 100 ohms, let's change it. Let's change that resistor out. I'm going to tack this on the bottom of the board just because I'm lazy. It was, where was it? It was right here. This is it here. And besides the fact I've only got this big bloody resistor here, I don't have a small one. I guess I'll find out when I turn on the power. Is it going to work or is it not? Alright. So what we had on this one is one of the output transistors failed. I replaced both of them. So we got both speakers going now. So here we go. Let me turn that volume down here. There's the volume control. So, okay. That resistor takes the minus 15 volts over to the op amp, and it went open. Now, this transistor was the one that I think had a short internally. Being that they are Darlington transistors, you can't really measure them, because like you can measure for a short between the collector and the emitter of this transistor, right? And you can measure for base to collector short for this transistor, but you can't test whether you got a problem on this one. You could have a short across here, and you never see it. You have a short across a base to emitter on this transistor, because there's two transistors in the same package. So they're tough to measure with the meter. You get all kinds of weird results. So I changed both of those transistors and that one resistor right there, and this board is fixed. So the old Harris Stereo 5 board, which has been modded to mono, but I'm sure it could be put back to stereo. I'm sure they've just bridged the inputs. It might even be this bodge work right here. I don't know what they've done here. It's coming out. They're coming out of balancing and unbalanced to unbalanced transformers inside here. But anyway, it's functional. No more hum. Other than the hum that I'm getting because I'm not using shielded cables, but good for AM sound. Anyway, this one is fixed, so I'll say it.
Yeah.
No, I won't say it. I'll play it.
Big up to all the viewers. Listen to the vibes. Down in the heart of the beat, we're rolling tonight. 12 all vids, got the spark, everything's alright. From cars to the sounds that make you feel free. We're grateful for the love, you're the family. Late nights and bright lights, cruising the lane. With every video drop, you're calling our name. So we sing it loud, let the world hear our sound.